Hello, my name is TTJ Kepsi and welcome to my YouTube channel. Today our discussion on indices will be on equation involving indices. Last, I introduced you to what indices is. We also look at some rules governing indices and their application. We also talk about some properties governing indices and their application. We will also learn how to write indices in their index, some numbers in their index form, using prime factorization. If you have not watched any of these videos, please check it out on YouTube. Today, before the video ends, we will talk about equation involving indices. And when we talk about equation involving indices, we are talking about linear equation, quadratic equation, and simultaneous equation. So before the video will end today, our attention will be focused on linear and quadratic equation. I will introduce you to how to solve indices problem involving linear equation, how to solve indices problem involving quadratic equation, and we'll take some WASI questions and find solutions to them. This will be a very interesting engagement, so please come with me. So we start things off with linear equations involving indices. So linear equation involving indices, this employs an idea that if the two sides of an equation are having the same base, then we can equate the exponents. It's as simple as that. So for instance, if I have a exponent x and it's equal to a exponent k, since the bases are the same, then we can say x is equal to k. That is very easy. And knowing the rules and the properties governing this will be a very simple approach. So please, we'll take some sample questions, especially WASI questions involving linear equations, and we'll find solutions to them. Okay, so we'll find solution to the first question. So if 3 exponents x is equal to 9, we are finding the value of x. So your task is to make this number that is not in an index form, you write it in an index form. So 3 exponent x, 9 in an index form will be 3 exponent 2. That's 3 times 3 is 9. So since the bases are the same, we can boldly say our s is 2. Very easy. Very, very easy. We'll solve the second one. Now let's look at this one. Look at this. So your task is to make the two sides of the equation have the same base. So look at it. 4 exponent negative 3s can be equal to 1 over 64 is 4 exponent 3. 4 times 4 times 4 is 64. You can rewrite this again. So we have 4 exponent negative 3s will be equal to 4 exponent negative 3. Remember that property of indices. Please check out the videos on properties of indices. So we have 4 exponent negative 3s is equal to 4 exponent negative 3. Look at it. The bases are the same. So we can equate the exponent. Negative 3s equal to negative 3. What do? We divide both sides by negative 3. So s will be equal to 1. Very easy. So that's it. The value of s is 1. We'll solve another example so that you'll be abreast with the concept. Now let's look at the third question. Please, you can pause the video and see if you can find solution to this. Now compare your answers with mine. So remember, our task is to make this have a base of 2. So we can say 2 exponent s is equal to, this number is same as 125. Look at it, 1, 2, 3 over 1000. 125 divided by 1000 is 0.125. Our 2 exponent s will equal to 125 will divide 1000 8 times. So we have 1 over 8. So 2 exponent x will be equal to 1 over 8 is 2 exponent 3. So we can rewrite this using the properties. So 2 exponent s will be equal to 2 exponent negative 3. So now since the bases are the same, we can equate the exponent. So our s is negative 3. I hope you had negative 3. Please, if you got that, congratulations. If you have not, please go over the video and I know that you will get a concept. We'll solve some sample questions again so that you get a concept. Okay, so we'll solve the fourth question. Please pause the video because I believe in you And I know you can solve. Pause the video and see if you can find solution to this one too. It's a WASI question. Now compare your answers with mine. So remember, we learned that when two indices are multiplying with the same base, we add the exponents. So we can say this is 3 exponent 2x plus 1 all over. Since they are multiplying, we add the exponent. We repeat just one base. So 3 exponent 3x minus 4 plus 6 minus 7x will be equal to 27 exponent x. So we can simplify this. We have 3 exponent 2x plus 1 all over 3x minus 7x. So that will be 3 exponent negative 4x. 3x minus 7x will be negative 4. Negative 4 plus 6 will be plus 2, will be positive 2. And this will be equal to 27 exponent x. What do you do? You can rewrite this as 3 exponent 2x plus 1 divided by 3 exponent negative 4x plus 2. And to be equal to, I can change this to have a base of 3. So we have 3 exponent 3 is 27. Then we attach our s. Now remember the law of indices. When two indices are divided with the same base, we subtract the exponents by repeating one of the base. So we'll use that concept here. Now applying the law, we'll have 3 exponent 2x plus 1 minus negative 4x plus 2. And to equal to 3 exponent 3x. Now we expand this. We have 3 exponent 2x plus 1. This negative will affect it. We have plus 4x. Then minus 2. And to equal to 3 exponent 3x. So 2x plus 4x will give us 6x. Then 1 minus 2 will be negative 1. And to equal to 3 exponent 3x. Now the bases are the same. So we can equate the exponents. We say 6x minus 1 will be equal to 3x. What do? We group like 10. 6x minus 3x will be equal to 1. I transpose this and send that one. 6x minus 3x will be equal to 3x. And that will be equal to 1. We divide both sides by the coefficient. Our s is 1/3. I hope you got the same answer. We'll solve one more WASI question on linear equation involving indices. Please, you can pause the video as I've been saying and try solving. And I know you'll get the answer. Now compare your answers with mine. So what do? Our task is to make the basis of the two sides of the equation the same. So we can change this to base 3, this to base 3. Remember, the square root of every number is that number exponent half. So the square root of 3 is 3 exponent half. So what do we have? We can change this to be 1 over 3 exponent 3. 27 is 3 exponent 3. Exponent 2x minus 1. And to be equal to 243 is 3 exponent 5 times 3 exponent half. The square root of 3 is 3 exponent half. So we can rewrite this using the properties. You can rewrite this as 3 exponent negative 3 times 2x minus 1. That's exponent 2x minus 1 is equal to 3 exponent 5 times 3 exponent half. Remember the third law. When we have an indices being exponented again, we repeat the base and multiply the exponents. So this will be 3 exponent negative 3 times 2x minus 1 and to be equal to. Also, when two indices are multiplying, please, the dot means multiplication. When two indices are multiplying with the same base, we add the exponent by repeating one of the base. We have 3 exponent 5 plus half. So let's expand this. We get 3 exponent negative 6x Negative 3 times 2s will be negative 6s. Negative 3 times negative 1 will be plus 3. And to equal to, now 5 plus half. Look at it. 5 plus half. Remember, 5 is over 1. The LCM will be 2. 1 will divide, 2 divided by 1 is 2. Times 5 will be 10. Then 2 divide 2 once times this one will be 1. So that will be 11 out of 2. So you can say this is 3 exponent 11 out of 2. So now, since the bases are the same, we can just equate the exponents. So now let's equate the exponents since the bases are the same. So you can say 6s plus 3 will equal to 11 over 2. You can multiply through by 2 to eliminate the fraction. So both sides by 2, this by 2. 2 times negative 6s will be negative 12x. 2 times 3 will be plus 6. And to be equal to these 2 divided by 2 will be equal to 11. So our negative 12s will be equal to 11 minus 6. Negative 12s, 11 minus 6 is 5. Now divide both sides by the coefficient of the variable, negative 12s. Negative 12, negative 12. So the negative 12 divided by negative 12, s will be equal to negative 5 over 12. I hope you have the same answer. That's wonderful. So our next discussion will be quadratic equations involving indices. Come with me. Okay, so our next discussion will be on quadratic equation involving indices. They are the indices problems that are in this form. Remember, the general form of any quadratic equation can be ay squared plus by plus c equal to 0. So if the indices problem is given to you, try to express it in this form. When you express it in this form, then see k exponent s is common to them, common to it. So you can just let that k exponent s be equal to any variable, say y. So from here we can say let k exponent s be equal to y. So any place we see k exponent s, we substitute y. So in this place we can have a. So in place of k exponent s we put y, then our square, plus this place to y, so by, then plus our c equal to this, equal to 0. Now we have reduced the indices problem into a simple quadratic equation. Now after we solve the quadratic equation, we get the values for y. When we get the values for y, we substitute the y into this equation and find the value of x. It is a very interesting one. We'll take some sample questions that are all WASI questions. Then we'll try to find solutions to them. So now let's solve our first question on this. They say solve for s if 3 exponent 2s minus 4 3 exponent s plus 3 is equal to 0. Now how do we solve this? So we have to reduce the indices problem to a simple quadratic equation. How do we do that? Look at this. You can rewrite this as 3 exponent x squared, which is the same as s times 2 is to the 2s. I've not changed anything. Minus 4 3 exponent x plus 3 is equal to 0. Now look at it. 3 exponent x is common to this and that. So we let it be equal to any variable. So we say let 3 exponent x be equal to y. So in place of 3 exponent s, we substitute y. So in place of this 3 exponent s, we put y, then square, minus 4, in place of 3 exponent s, y, plus 3, and to be equal to 0. So we have succeeded in reducing our indices problem into a simple quadratic equation. Now we solve. Remember how to solve quadratic equation. You first check the coefficient here is 1. If it is, then you find the factors of the constant. That if you add, you get the linear term. And when you multiply, you get a constant. So that factors are negative 3 and negative 1. Negative 3 plus negative 1 will be negative 4. and negative 3 times negative 1 will be 3. So now we have y squared minus y minus 3y plus 3 and to be equal to 0. Please check out my videos on how to solve quadratic equations. Check out. So we have this. What is common here? Y is common. We bring it out. Y minus 1. What is common? 3. So 3 out. Y minus 1 equal to 0. Now y is common. We can factor it out. Y minus 1. Then y minus 3 will be equal to 0. So now if we take each of these and equate it to 0 and find the values of y. And remember, 3 exponent s is equal to y. So now we take each of these. So y minus 1 equal to 0, y will be equal to 1. And y minus 3 equal to 0, y will be equal to 3. And remember, 3 exponent x is equal to y. So we can say that 3 exponent s, one of the values of y is 1. So we can say 3 exponent s is equal to 1. Now we have to change this one to have a base of 3. Remember, when we're learning properties of indices, we say any number exponent 0 is 1. So we can say that this one can be 3 exponent 0. So since the bases are the same, we equate the exponent. S is equal to 0. The second one, our 3 exponent s is equal to 3. 3 exponent s, this 3 to be written and index form will be 3 exponent 1. The bases are the same, so we can equate the exponent. So s is equal to 1. So we can boldly see that our s is 0 or 1. Please, I hope you get that. We'll solve another one so that you will be abreast with it. So let's look at the second question. Please pause the video and try solving. Now you can compare your answers with mine. So find the value or the values of s if 2 exponent 2x plus 2 minus 9 2 exponent x plus 2 is equal to 0. Now remember, our task is to reduce the indices problem to a simple quadratic equation. So now when we are solving indices, we say when the bases are the same, we just add the exponent. So we can rewrite this in the form 2 exponent 2x times 2 exponent 2. So since the bases are the same, we just repeat the base and add the exponent. We'll come back to that. So minus 9, 2 exponent x plus 2 will be equal to 0. So our 2 exponent 2 is 4. That's 2 times 2. We can have 4 bracket 2 exponent 2x minus 9, 2 exponent x plus 2, it will be equal to 0. What next? We rewrite this to look like this. So we have 4 bracket 2 exponent s times 2. This is the same as that. Minus 9 bracket 2 exponent s plus 2 equal to 0. So since we have 2 exponent s at the two sides, we can say we'll let 2 exponent s to be equal to any variable, say y. So in place of 2 exponent s, we substitute y. So in this place, we have our 4. This will be y, then square. Minus, this will be y. 2 exponent s is y. So we have 9y plus 2 will be equal to 0. So this is a quadratic equation. We check whether the coefficient here is not 1. So we multiply this coefficient by the constant. 4 by 2 will be 8. So 4 by 2 is 8. We find factors of 8. That one add we get negative 9. One multiply we get 8. Those factors are negative 8 and negative 1. Negative 8 plus negative 1 will be negative 9. Then negative 8 times negative 1 will be 8. With positive 8. We replace the linear term by those factors. So we have 4y squared minus 8y minus y. That's negative 8 and 1. Plus 2 equal to 0. Please check out my videos on how to solve quadratic equations. What? We factor out common factors. What's common here? 4y is common. You have y minus 2. What's common here? Negative 1, y minus 2 equal to 0. So factor out y minus 2, we'll be left with 4y minus 1 to be equal to 0. You take each of them, equate it to 0. So y minus 2 equal to 0, our y will be equal to 2. Then 4y minus 1 equal to 0, our y will be equal to 1 out of 4. Remember, we are not looking for the value of y, but rather the value of x. But we say that 2 exponent s is y. So since we know the values of y, we substitute. So our 2 exponent s, since it's equal to y, we can say it's equal to 2. 2 exponent s will be equal to 2 exponent 1. Since the bases are the same, we equate the exponent. So s is 1 there. The same place, the same vein here. 2 exponent s will be equal to 1/4. So 2 exponent s will be equal to 1 over 2 exponent 2. 2 exponent 2 is 4. We can rewrite this as 2 exponent negative 2 using the properties. So now the bases are the same. We equate the exponent. So we can say our s is 1 or negative 2. I hope you got the same answer. We'll solve more questions on this so that you get a concept. So one more was equation on this quadratic equation involving this. Please pause the video and try to see if you can find solution to this. It's very easy. So what do we do? Let's expand this first. We'll have 2 times 1 will be 2 plus 2x minus 3 exponent x equal to 3 exponent x plus 3 minus 3. What do? We apply the laws. When two indices are multiplying with the same base, we add the exponent. So we change it back to that. We say this will be 3 exponent 2 dot 3 exponent 2x minus 3 exponent x equal to the same way to this one. This also will be 3 exponent x times 3 exponent 3 minus 3. So 3 exponent 2 is 9. We have 9, 3 exponent x times 2. You can rewrite that. Minus 3 exponent x will be equal to 3 exponent 3 is 27. So you can say 27 bracket 3 exponent x minus 3. So what next? Since we have 3 exponent s common to them, we let any variable to be equal to that. So we said let 3 exponent s to be equal to y. So in place of 3 exponent s, we substitute y. So we have 9. In place of this 3 exponent s, we have y. Then our square minus y will be equal to 27. 3 exponent s is y minus 3. Now remember, 3 exponent s is equal to 3. We group like terms and solve this quadratic equation. So now let's transpose everything here and equate it to 0. We have 9y squared minus y minus 27y plus 3 will be equal to 0. And we have 9y squared minus y minus 27y will be minus 28y plus 3 will be equal to 0. Now to solve this quadratic equation, you multiply the coefficient here by the constant. So 9 times 3 will be 27. Factors of 27. When we add, we get negative 28. We multiply, we get a 27. Then when we find our factors, we replace the linear term by those factors. So those factors are negative 27 and negative 1. Negative 27 plus negative 1 will be negative 28. And negative 27 times negative 1 will be 27. So now since we find the factors, we replace the linear term by that. So that will be negative 27 and negative 1 plus 3 will be equal to 0. Now we factor out common factor. What is common? 9y is common, y minus 3. Negative 1 is common, y minus 3 to be equal to 0. So we have 9y minus 1 and factor out y minus 3 and to be equal to 0. Now we take each of the bracket, equate it to 0 and find the values of y. So 9y minus 1 equal to 0. Our y will be equal to 1 out of 9. Then y minus 3 equal to 0. Our y will be equal to 3. But remember, we don't need the values of y. We need the values of x. But 3 exponent x is equal to y. So we can boldly say that since y is equal to 1 over 9, our 3 exponent s is equal to 1 over 9. So 3 exponent s, 1 over 9 in an index form with 9 in an index form with 3 exponent 2. You can have 3 exponent s is equal to 3 exponent negative 2 using that property. So our s will be equal to negative 2. Since the bases are the same, we equate the exponents. Also, our 3 exponent x will be equal to this 3. Remember, since 3 exponent s is y. So our 3 exponent s will be equal to 3 exponent 1. Since the bases are the same, we equate the exponents. So we can boldly say that our s is equal to negative 2 or 1. I hope you got the same answer. We'll solve one last question on this so that you'll be abreast with it. So we'll solve one last question on this. It's also a WASI question. Please remember to subscribe to the YouTube channel if you are yet to, and click on the notification bell so that anytime I post a video on any of this, you'll be the first to receive it. Now let's get into it. They say given that s exponent 2 third minus s exponent 1 third minus 6 is equal to 0. Find the value or the values of s if s is greater than 0. So what do? We solve this. We have s exponent 2 third minus s exponent 1 third minus 6 is equal to 0. So what do? We have s exponent 1 third here. So we rewrite this to look like that. So we have s exponent 1 third times 2. 1 third times 2 will be 2 third. Minus s exponent 1 third minus 6 will be equal to 0. So what do? Let s exponent 1 third to be equal to any variable, say k. So what do? We replace any place we see s exponent 1 third, we substitute k. So in this place we have k squared minus k minus 6 will be equal to 0. Then this becomes a simple quadratic equation where we solve. Now remember, the coefficient here is 1, so we find the factors of 6. When we add, we get negative 1. We multiply, we get negative 6. Those factors are 2 and negative 3. 2 plus negative 3 will be negative 1. And 2 times negative 3 will be negative 6. So we replace the linear term by those factors. You have k squared minus 3k plus 2k minus 6 equal to 0. Now factor out common factors. What is common here? K is common. K minus 3. What's common here? 2 is common. K minus 3 equal to 0. So now k minus 3 is common. Factor out. We'll be left with k plus 2. So when we factor out our k minus 3, we'll be left with k plus 2 and equal to 0. So we take each of the brackets, equate it to 0. So k minus 3 equal to 0. Our k will be equal to 3. Then k plus 2 equal to 0. K will be equal to negative 2. Now remember, we don't need the values of k. Rather, we need the values of x. But s exponent 1 third will be equal to k. So what do we have? We can say the s exponent 1 third is equal to 3. How do we solve this? To eliminate the fraction, we keep both sides. So this 3 will divide that, we'll be left with x. That's s exponent 1, which is s. 3 exponent 3 will be 7. That's for the first one. The second one too, s exponent 1 third will equal to negative 2. The same vein, To eliminate the fraction, we keep both sides. How do we have? This will divide our s will be equal to, we'll be left with s will be equal to -8. So our s is 27 or -8. But remember, in the question, they say s is greater than 0. So let's see. So you can see -8 is actually less than 0, so we don't need this. But 27 is greater than 0. So we can boldly say that our s is equal to 27. I hope you understand this. I hope you understand. Please remember to subscribe to the YouTube channel and click on the notification bell so that anytime I post more of these videos, you'll be the first to receive it. Until we meet again, my name is Tete Jacob Richie. Bye-bye.